Hello guys, welcome to today's tutorial. Today we'll talk about algorithm. We'll discuss algorithm into detail. We are going to use simple concepts to know how algorithm works. Also, I'll be introducing you to some popular algorithms. We'll look at this algorithm, we'll see how it works, and by the end of the day, you'll be able to, by the end of this tutorial, you'll be able to generate your own algorithms to solve basic to complex problems. So stick with me whilst I take you through this process. So what is an algorithm? Basically, algorithm is a step-by-step procedure of solving a problem at hand. So what do we mean? Let's consider an example where we have 5 students in a class and they have been told to find the sum of 3 numbers. So let's look at this example. Let's say the numbers we have in the class, the number that the student have been tasked to sum is 4, 6, and 8. So these 3 numbers, the students have been tasked to add these 3 numbers. For instance, the first student can say, let's add 4 plus 7, and we get 11. Then we now say the sum, then plus 9, then we get 20. So the first student says the sum of the 3 numbers is 20, and the procedure he has used to get this is to add the first number plus the second number. Says the answer is 11. Then now the sum is getting for the first and second number is adding it to the third number to get the 20. This is one way one of the students have decided to solve the problem. Now let's look at another student. Another student can say, these are 3 numbers, so let me add the last number, which is 9, plus the second number, which is 7. Now the answer is 7 plus 9, that should be 16. Now the student can now say, now that he has gotten 16 as the sum of the third and second, he can easily add the sum to the first number, which is 4. Now 16 plus 4 is obviously 20. So now you can see this is a problem at hand, and 2 different students have decided to solve the problem, which is the sum, in different ways. These 2 different procedures they have used, we refer to each of them as algorithm. The students have been able to formulate an algorithm to solve the problem at hand. So this skill of formulating a procedure to solve the problem at hand is what we need of you as a software developer or as a programmer. You should be able to look at the problem at hand and devise simple steps. Simple is very important. You can't devise a complex step. Simple steps to solve the problem at hand. Now, what are the characteristics of an algorithm? The first characteristics we should look at is the input. All algorithms have input. For instance, the previous example we cited, that's the algorithms where students are tasked to add numbers. Obviously, the inputs in this problem, they are the list of numbers the students are supposed to find the sum. So in this case, all algorithms should have input. Now the next characteristics is output. Obviously, algorithm is to solve a problem. So at the end of the problem solving, there should be an output which is the solution to the problem. So when you have an algorithm, so far as there is input, there's supposed to be an output. Now the next characteristics we'll be looking at is definiteness. Definite. When you are solving a problem, the definiteness characteristics means that all algorithms should end. It should start as a procedure, and after executing the set of procedures that you've designed, there should be a point where it ends. It's done solving the problem, so there should be a point where your algorithm stops. The next characteristic is effectiveness. Each step in the problem you are solving should be understandable, should be basic enough for comprehension. When we look at your list of procedures you've listed, the procedures you've listed to solve a problem, we should be able to understand each step you are taking. So all this makes up the characteristics of an algorithm. Now let's look at some of the popular algorithms out there. The first one we should look at is sorting algorithm. Sorting. There are popular algorithms that people have sat down and designed algorithm to sort numbers. For instance, we have bubble sort, we have insertion sort, and so on. So some people have actually devised an algorithms to undo sorting. And also there's another algorithm on searching. We have linear search, which is one of the most basic algorithm. We have linear search, we have binary search. So what I'm driving at is that people actually have devised ways to solve problems in all these areas: sorting, searching, sorted path in graph, minimum spanning tree, primality testing, traveling salesman, knapsack problem, chess. All these things, people have actually devised ways of solving them. We are not going to look at the algorithms deeply, but I just want you to know that people are actually taking their time to generate algorithm for public use. So you can, you also as an individual can devise algorithms for public use as your contribution as a programmer. This should be one of your skills. Like I mentioned earlier, you should be able to devise ways to solve known problems. Now let's discuss algorithm complexities. Although we will not dive into this analyzing complexities now, but I want you to have brief knowledge, some of the basic things you need to consider now that you are learning how to do an algorithm. There is something we refer to as time complexity. Time complexity. That means how long will you take to solve a problem. So also you should take note of that. Your algorithm should not take too much time to solve a particular problem. And also we also have size complexity. The space required of your algorithm to run should also be minimal as much as possible. Although you might not know much about this, but I want you to have it in your mind that there's something we refer to as time complexity and size or space complexity of an algorithm, which refer to as how long is your algorithm taking, and how much size does it need to run, does it need to work. So just have these two in your mind, or later in this my subsequent tutorial I'm going to treat the time complexity and space complexity exclusively. Now let's discuss algorithm design strategies. Based on the fact that we are still learners, learning how to develop an algorithm, although there are several strategies, but the one I want you to take note of is what we refer to as divide and conquer strategy. Divide and conquer. Divide and conquer is just as the name depicts. You break the problem into pieces, into parts. You solve each part, and at the end of the day you are done solving the problem at hand. For example, the example we looked at in the first and early in this tutorial, where we tasked students to add 3 numbers. You see, the task at hand is to add the 3 numbers, but we broke the strategies we used in summing this number is to add the first 2 number, then later add the last number. So in this case, you see that we've broken the big problem into smaller parts. We'll solve these smaller parts, and then the end of the day we are done solving the problem. This is the one of the popular strategy in designing or in creating an algorithm. We'll get the bigger picture, then we'll break the bigger problem into bits, and we solve these bits, and at the end of the day we are done solving the problem. So as a beginner, this is the type I want you to be practicing. Now let's do a recap of all what we've learned so far. First, we've learned what algorithms are. We've defined an algorithm. We've spoken about the characteristics of an algorithm, which involves input, output, definiteness, and then effectiveness. All algorithms should have these 4 characteristics. And also we discussed about the strategies of algorithm development, and I recommended that you stick to divide and conquer as a beginner for now. Make sure you practice using the divide and conquer algorithms. And also I made you know that there are several algorithms that already exist to solve problems. There are search algorithms, there are sorting algorithms that people have worked on and have made available for the public use. And I also recommended that as a developer you need algorithm generator skills. That skill is very important for you as a software developer, as someone who wants to be a software developer. You need to work on your algorithm generation skill. You should be able to analyze a problem and propose and profile a perfect algorithm to solve this problem. Yeah, so I'm sure you might have some questions. Feel free to add them to the comment section. I'll be happy to answer them. And also make sure you like this video, you share among your mates, and you subscribe so that whenever I drop the subsequent videos, you get notified, then you will not miss out on any of the contents I provide.